Now, the last model that we are going to cover in this inventory management chapter is single period inventory models, or it is called news vendor model. So far, we have considered inventory decisions in which demand continues in the future and future orders will be placed for the same product. There are some products for which a decision to meet the demand for a single time period is made, and items that do not sell during this time period are of no value or have a greatly reduced value in the future. For example, a daily newspaper is worthless after the next paper is available. Other examples include weekly magazines, programs printed for athletic events, certain prepared foods that have a short life, and some seasonal clothes that have greatly reduced value at the end of the season. This type of problems often called the news vendor problem or a single period of inventory model. Finding the inventory level with the lowest cost is not difficult when we follow the marginal analysis procedure. This approach says that we would stock an additional unit only if the expected marginal profit for that unit equals or exceeds the expected marginal loss. This relationship is expressed like this. So we have probability P equals demand will be greater than or equal to a given supply, and 1 minus P is the opposite of that, probability that demand will be less than the supply. And if we use this marginal approach, marginal analysis, we have expected marginal profit equals P, probability that demand will be greater than or equal to a given supply, times marginal profit, MP, right? So PMP is the expected marginal profit, and the expected marginal loss is the opposite of that, 1 minus P times marginal loss, right? So we have marginal profit and marginal loss. And if you use that, the optimal decision rule is that stock the additional unit if P times marginal profit, the probability of that is greater than 1 minus P times marginal loss. And this is the logical result of the rationalization of the cost, inventory cost. And if you just manipulate that a little bit, then you will get PMP is ML times ML minus MP. I'm sorry, ML times P. So we have ML minus P times ML. And therefore, if you rearrange it, PMP plus PML has to be greater than equal to ML. And if you solve for P, then you have ML over ML plus MP, and the probability of this probability that this demand will be greater than or equal to a given supply has to be always greater than equal to this value. So let's see the three steps that we have to take for this marginal analysis. And this is the case for discrete distribution. Step 1, we have to determine the value of ML over ML plus MP. So marginal loss over marginal loss plus marginal profit. And the second step is construct a probability table and add a cumulative probability column. And I will show you what that means later. And step 3 is keep ordering inventory as long as the probability P of selling at less one additional unit is greater than ML over ML plus MP. So let's take a look at an example to understand these three steps. Cafe du Donut. This cafe buys donuts each day for $4 per carton of 2 dozen donuts, right? So one carton includes 2 dozen donuts, and you pay about $4 for that carton. And cartons not sold are thrown away at the end of the day because it's food and it is perishable product. And if a per carton is sold, the total revenue is $6, right? So $6 and you have $2 of profit for that. So if you have this case, you have to find marginal profit and marginal loss. And MP is marginal profit is that your revenue is going to be $6 and you subtract the cost from it, then you get $2. So your marginal profit is $2. And marginal loss, ML, equals $4 because your cost is $4 per carton. So then that's the information you have, and here is another very important information that you have to calculate if you are going to work on this or use this model for your understanding or for your business. So you have to find the probability that demand will be at this level, right? So how many of these cartons are you selling? And if there's a chance of 5% to sell 4 cartons, and the 15% to sell 5 cartons, and so forth. And here is the probability and your expected number of cartons to sell. And this table has to be ready so that you can move on to calculate these inventory models. So, kindly the problem provided us with this information and let's see how we can follow these 3 steps. The first step is determining the value of ML over ML plus MP, and we already found it. So the marginal loss was $4, marginal profit was $2. Therefore, it's a 67% of the chance. And it says the probability has to be greater than 67%. As long as it is greater than 67%, I think it's good for you to handle those cartons for your business. And the second step is to add a new column to the table that you have before and try to find the probability that donut sales will be at each level of or greater than that. So let's go here, and here is the 2 columns that we saw from the previous slide, and you have to calculate the probability that demand will be at this level or greater. And it's simply adding all these numbers up and putting it here. So if you add 0.05, 0.15, 15, 2025, 1010 together, it's going to be 1, right? And 1 is greater than 0.67, so this is acceptable daily sales that you want to use. The second one is 5, and you have 15%, and now you exclude the category that you used. So you exclude this one, and when it is 5, it's 15, 15, 20, 25, 10, 10, and they give you 0.95 as your percentage, which is still greater than 0.67. Therefore, this is a good one. And the third one is when you are selling 6 cartons, and that's 15% of chance. And if you add this probabilities up, then you have 80%, and that is greater than 0.66, and which is good. And then you come to 7, and that's 0.20. You add 0.2025, 10, 10, then you get 0.65, right? And 0.65 is less than 0.67. Therefore, this is not acceptable inventory. So in this case, what you can choose is actually 6, right? 6 is the optimal number that you should choose. Therefore, the answer in this case is 6 cartons for your order. Let's also take a look at this marginal analysis with the normal distribution. So say if we have normal distribution rather than discrete distribution, your formula changes slightly. The first step is the same. Determine the value of ML over ML plus MP because we are using marginal analysis. Step 2, locate P on the normal distribution and find the associated Z value using this Z formula. Z equals X minus mu or X star minus mu over sigma. And using this formula, you can find X star. And step 3 is after finding X star, you want to use this relationship to solve for the resulting stocking policy, and you will be able to manipulate this one. So if you multiply by sigma over here and there, then you cancel this out. So therefore, you have z sigma equals x minus mu. Therefore, x star is going to be mu plus z times sigma, and it's derived from this formula. And using this, you can solve a question. Let's take an example. Say now we are going to use Chicago Tribune, and Chicago Tribune, 60 papers a day it's selling, and the standard deviation is 10, and marginal loss is 20 cents, and marginal profit is 30 cents. So this information is given. Then now we can jump into step 1, where we use this ML over ML plus MP formula, and we find 20 over 20 plus 30 gives you zero point 0.4, so your probability is 0.4. And in step 2, we have to find the X star, and you can find this one using norm.inverse function, and that is possible for you to find the X bar right away. And then you can use the formula and plug these numbers in. So say this is z is 0.25 when area under the curve is 0.40, and at the time your z value is 0.25, and to find that x star, you put 0.25 equals x star minus 60 over 10, and if you solve for it, x star is going to be 60 plus 0.25 times 10, and it gives you 62.5, or about 62 newspapers, or it could be 63 newspapers too, right? So that's how you can solve this question. If I just take a similar example with a different number, say you are selling 100 papers a day, and the sigma is still the same 10, and marginal loss is now greater than profit. Marginal profit 10 cents, marginal loss is 40 cents, and how is going to change your equation. So let's look at step 1. This is similar. So 40 over 50 is 0.8. So P has to be greater than or equal to 0.80. And you want to put this to 80% on your right tail, and you find that it expands into this left tail too, and you need to find this value. So if you use the formula, then you can find that this z value that corresponds to 80% is negative 0.84, and you plug them into this formula. Negative 84 is x star minus 100 over 10, and if you solve for x star, then you will get 91.6 or 91 newspapers. So that's how you can solve this newspaper problem. So in this lecture, we have covered inventory models. We learned why inventory management is significant. And we started with the EOQ model. EOQ model is the basis of many other models. We learned that there's two important portions of EOQ model. There was setting up cost and inventory carrying cost. And we found that if we set them equal and solve for Q, then we'll find the EOQ. Then we expanded this EOQ model to a situation where instantaneous receipt is not possible, and there was a production module, and we used daily demand and daily production for that. And fourth model was inventory model with the quantity discounts, and at the time we had to consider quantity discounts are falling into different groups, and by different groups we have to find the different EOQs and calculate the total cost that corresponds to the EOQs, and find the total cost with the lowest cost, and that's going to be your optimal EOQ. And we also learned about the safety stock. Safety stock in this era of disruption is very important, and having the desired safety stock level, 95% or 97% or 98%, that is a very important consideration to control the cost. And lastly, we learned about new vendor management problems or single period of inventory quantities, and that is covered in this lecture. I hope this lecture was helpful for you to understand various models for inventory control. Thank you.